All right, boys and girls, welcome back to the drive-thru. Sponsored as always by the deli. Hungry? Stop by the deli. Make yourself a meatball hoagie on white with provolone. All right, so do these two lines intersect is the question being asked. So what you have to understand is that these are symmetric equations right here. They're all equal to the same thing, and we'll call that thing T. These are also symmetric equations, but they might be equal to a different thing, so we'll call that thing S. If those things are the same, then maybe we'll find out that these things do intersect. So we can solve each of these for x. So 3t plus 0 equals x. Solve this one for y. Negative 1t plus 2 equals y. Solve that one for z. 1t minus 1 equals z. Okay, now over here we can say 4s plus 1 equals x. That is an s. This is an s, not a 5. 1s minus 2 equals y. And negative 3s minus 3 equals z. Okay, so since x is equal to 3t plus 0 and x is equal to 4t plus 1, we can say that 3t equals 4s plus 1. Okay? And then we can also say that negative 1t plus 2 equals 1s minus 2. Alright, let's see. Let's just multiply the bottom one by 3 and get negative 3t plus 6 equals 3s minus 6. Let's add this equation to this equation using the elimination method. So we've got gone 6 equals 7s minus 5, right? Yep. 12 equals 7s. So s is, thank you, Sabrina. S is 11 sevenths. S is 11 sevenths. Okay, now I'm going to just save a little time on this video, and we could do a very similar process. Well, hold on, let's just pop that in and find our t. I'm sorry. What did we decide? 3t is 4s plus 1, so 3t is 4 times 11 sevenths plus 1. 3t is 44 sevenths plus 7 sevenths, 51 sevenths. Okay? Divide each side by 3, and t equals 51 divided by 3 is 17, right? So t is 17 sevenths. So now we have our s, we have our t. They are different. That doesn't necessarily mean that these two things don't intersect. They could intersect at different times. But what we do is we plug our t in here for z, and you get 17 sevenths minus 1. So at that point, z would equal 10 sevenths. We have to get z equals 10 sevenths at the same moment for these to intersect. So plug in 11 sevenths for our s. You get negative 33 sevenths. I better write this out. Minus 21 sevenths, which is negative 54 4/7, and that is not the same as this, and now we know that they do not intersect. So what we found out is that there is a point where our x and our y have this, there is a time 17/7 for this line and 11/7 for this line. There is a time where our x and our y coordinates share the same thing, but since our z coordinates are not the same at that same time, these two lines do not intersect, which makes them skew. Another good math word. Boom!